It's really my pleasure to give you an overview of AI in healthcare. So looking back, what happened the past few years, but also looking forward, looking to the opportunities and the challenges that we still will need to solve. It's only a 30-minute talk, so we have the possibility to scratch a little bit the surface, but feel free to indeed ask questions or to send me an email afterwards if you would like to have some more information. I won't read the agenda. So introduction, then going to challenges, opportunities, and then some conclusions and looking forward. Allow me in 1 minute to give you a short introduction of Barco and Barco Healthcare, because it will help you to better understand the context of the presentation. Barco is a company active in a number of different sectors. As you can see here, healthcare, enterprise, entertainment. So it's a quite diverse company, but we're a technology-centric company, and in many of our markets, we're already using AI. In the healthcare business, you will find us in a lot of different specialties, a number of interesting ones, radiology.
Tom, may I introduce for a second? Can you share your screen?
Okay.
You're not sharing a screen.
Yeah, I thought it was shared already. Let me try again. Apologies.
That will be better.
Now?
Yes.
It is. Okay. Good.
Perfect.
Good. Yes. So I was on this slide. So active in a number of different sectors, in a number of specialties in healthcare, radiology, mammography, but also dermatology. And dermatology is specifically an area where we were able to gather quite some experience with AI in the past few years. More specifically with the Dimitra device, which is a digital dermatoscope, but that also has a lot of embedded analytics functionality that allows the users to get more insights. It's a digital system, cloud backend, web frontend, and so on. So this is, you will see this coming back in the remainder of the presentation. This is a device where we have a lot of experience with AI. Taking a step back, adoption of AI. AI is everywhere nowadays. I just randomly grabbed some screenshots. For example, this week or last week, there was the announcement from Mercedes that they are taking a step forward with really autonomous driving on the highways. There are also things like fruit sorting, picking of fruits and so on that are already and used in practice quite a long time. So AI is a reality already. It's not something that will that is yet to come. It's something part of our life already. Now, interestingly, if you look to the different sectors and the adoption of AI, then it will not surprise you that IT, telecommunications, is actually one of the sectors with most adoption. Going down a little bit, healthcare is only at the bottom of the list. So that's quite interesting. It's an interesting question. Why would it be that healthcare is lagging behind a little bit in real adoption of AI? Another interesting statistic that I really wanted to share with you is regulatory approvals, regulatory clearances. So medical devices that use AI that have been approved, certified for use. As you can see, there have been some long time ago, and then not much happened actually until, let's say, 2014-15, and then a gradual increase has taken place. But it's still very limited because these are really worldwide, so all products approved or cleared by FDA. So it's not that broad yet. If you look at who is actually doing that, and this is also quite an interesting statistic, a lot of these medical products with AI come from startup companies. So this is the dark green part. The majority comes from startups, which probably also already makes a statement. The rest then comes from the bigger companies, the bigger medtech companies, very few from diagnostics and pharma at this moment. So in healthcare, it's clear that AI has really huge promises ahead. If you go to conferences, congresses, and you talk about AI, people will tell you it's really promising because it can give you higher efficiency, higher throughput of patients. It will give lower cost for payers, society, and providers, better quality of care, faster access to care for patients. But, and that's a big but, in reality, you don't see it that often yet. If you walk in a hospital or you go to a dermatologist, very, very, very few providers will have AI, and even fewer will use it in regular clinical care. It's kind of a niche application today in many cases yet. And at the same time, what you also see is that many AI algorithms don't make the step from the lab to product. You see a lot of scientific publications with nice results. You see a lot less products that are certified. And then of the certified products, there are even a factor of 10 or even less that make it into real volume use. So why is that? Maybe have a look at AI in healthcare. So what makes that different from other sectors? What is particularly different, challenging? And I just list a few of the topics, and I will go through them. So first of all, it's life critical. And I do realize there are other sectors that are also life critical, but healthcare for sure is life critical. And just one statistic here on the right to indicate that. This is an example of skin cancer, melanoma. So if you can find melanoma early, then your 5-year survival rate is extremely high. In other words, you can treat it quite well if you find it early. If you're later, it becomes problematic. So if it's stage 3 or 4, your survival rate is really low. So that's life critical. Means that if you have an AI algorithm and it works well in the majority of the cases, even those few situations where it goes wrong can have a huge cost. So it's really a true life critical application. But it's also a complex ecosystem, a very complex environment, because one and the same algorithm could be used by more stakeholders or multiple stakeholders in the care team that each have less or more experience. And it's almost impossible to give the same algorithm to all of those stakeholders. Just to give you an example, a dermatologist could use an AI algorithm, but a dermatologist is really specialized and could use that AI as an addition to his or her own expertise. Give that same thing in the hands of patients, and it's a recipe for disaster, because patients are obviously not medically skilled, and they should and cannot just rely on the algorithm. And then you have a whole spectrum in between. You have GPs, you have secondary care, pharmacists, and so on. So it's a complexity because the same algorithm cannot be deployed into different stakeholders. You really need to well understand to whom am I deploying it, and what does that mean for the type of results, the type of information that I should provide to those stakeholders. So even if an algorithm underlying under the hood is using the same network architecture and is doing a classification, sometimes you want to actually expose that classification, sometimes you don't because of the user that will use it. So this is a very important thing to take into account. Regulatory, obviously. Healthcare is heavily regulated for good reasons, because indeed you need to ensure that healthcare products are safe, reliable, are effective for what they do. There is a lot of different regulations, and I won't go into details, but they really determine not only how you need to test the product, but even how you need to develop the product, the process you need to follow on how to develop the product. And specifically for AI, regulators started coming up with guidances, with real clear regulations, instructions on how to handle AI algorithms. There are some interesting references here. You can click on the links later on. But especially FDA is really active. Europe as well, but FDA is a little bit ahead, where they have guidelines for software as a medical device, AI-based software, but then also clear guidelines on how should you develop an AI algorithm with clear instructions of how do you need to create test training data sets, what information can a data scientist have access to or not, So it's really complex. And as a medical device company, you strictly need to adhere to those. Otherwise, you will never pass certification. Privacy. This is not exclusive for healthcare, but it's more stringent than healthcare because healthcare information, personal health information, is a special class of data. And the regulations are more strict. The rules you need to follow are much more strict when you touch healthcare data. So it's something you really need to take into account. That is slowing you down sometimes, that makes you think more ahead. And I want to stress it's extremely important to do it properly, not only because you will run into legal problems otherwise, but also because it can create huge business damage if you would have an issue with privacy that hits the press. What about data? Everybody knows data is crucial when you want to develop AI algorithms. Well, it's complex. For example, just listing a few things. Standardization on labels and outcome. So you collect data in hospitals, the data is labeled or has ground truth, but there is no or very little standardization in how the data is labeled or even the terminology. Some people will call a certain condition with one name or one term, and other people will call it differently. So you have a big variety, a big variability in what you get in as data. And that makes life more difficult because it means you really, when you get your data in, you need to do a complete translation exercise to make sure you standardize. Otherwise, you will offer your training algorithms with too diverse data that is actually not clean. Access to data sets is another challenge. Because of the healthcare privacy regulations, it's very hard to get access to sufficient data. It's easy to get small data sets for a lot of different applications in healthcare. And those small data sets allow you to quickly make a proof of concept, to scientifically validate something, to make a scientific publication and show that there is potential. But typically those data sets are not big enough to really develop and train a reliable algorithm that is also tested in a sufficient way. Very often you also suffer from unbalanced data. So the example of skin cancer that I gave you, if you start collecting data, luckily most people don't have skin cancer, but it means that if you prospectively collect data going forward, the vast majority of cases will be benign cases, healthy cases, meaning that you have very little training data for melanoma or for skin cancer. That makes it also more challenging. Yeah, not necessary to say a lot about this, but it's like in any AI training situation, it's always making a compromise. How much data do you want to collect? So when do you think your performance is good enough? And the challenge with generalization, you need to keep on adding data, but avoid that you overtrain. A few things that I want to mention specifically related to getting access to data in healthcare, for healthcare applications. It's always recommended to find a healthy mix between public data sets, where you likely need to acquire a license if you want to use it for commercial purposes, and then doing some clinical trial to collect your own data. So this is always a balancing exercise between cost of the data collection, speed of getting access to the data. Licensing is much faster than starting a clinical trial. But then also, on the other hand, if you license an existing data set, yeah, it will have different characteristics than the data you would collect of your own. Quality of the data is not always ideal. Usefulness, sometimes there is restrictions on what you can use the data for. So typically, when you train an algorithm for healthcare, you try to balance those existing sources and combine licensing and using existing data sets with clinical trials. Going forward, and this is something you really need to think about early on. Structured data is something in your product. When you design your product, make sure it has structured data and log everything you can with respect for privacy, because everything you log, you can use later on for improving the product. This is also a very important one. There is a huge difference between AI performance you find in the lab and AI performance you find in real clinical practice. So just one remarkable example is the yearly ISIC challenge on dermatology, where in 2018, let's say it was a normal challenge, typical on a certain task that needed to be performed. And then in 2019, they tried to make it more realistic with adding more real-life data into the data sets. And what was seen was a huge drop of 25% in the performance of the winners because the data was more realistic. And this is actually something that you see in reality as well. If you test your algorithm in a lab-controlled context, you can reach quite high performance. But once you start with using real-life data, things become much more complex. Why? Because in real life, people do not follow scripts, do not follow rules, do not follow clinical trial protocols. Just a few examples: using markers on images, using other type of equipment. So it makes that the input data has different characteristics, and this really impacts also the performance of your AI algorithm. Yet another example here. Take an AI algorithm trained to find melanoma, skin cancer, and it was trained for one type of device that would acquire images, and then you feed it images taken with another device. If you don't do anything special, you drop 13% in performance, which is really unacceptable in a healthcare space. Think about the cost of errors. Well, 13% is just not acceptable. There are ways to overcome that. So instead of doing something like this, where you use a camera that you click on a dermatoscope, you can actually create a device which is all-in-one and controls the acquisition settings. And that will reduce a lot the variability of the images and therefore give you higher chance of achieving more robust, more reliable performance. But in any case, you can do whatever you want with your device. It's best practice to, in your algorithms, when you infer your AI algorithms, when you apply the AI algorithms in real practice, to embed, to integrate technology that can detect outliers, that can detect when the algorithm is fed with an input that is looking strange, that is not seen in the training set. So it's best practice to make sure you do that. Coming to another topic, performance evaluation of AI algorithms. And I'm not going to make this a statistics training session of half an hour or longer, but there are clear methods to assess performance of how well does an AI algorithm work in a healthcare setting. And actually the main two things are sensitivity, what percentage of the cancers can you find, and specificity, what percentage of false positives are there. So in other words, where the algorithm says it's a cancer, but in fact, there is nothing wrong. And then you can plot fancy graphs and so on. So that's clearly something that you should use. But in reality, I can only recommend you complement that with other things as well to get better insights. Human evaluation, data sharding, confusion metrics. Use anything you can to better understand when is the algorithm really working and when is it still facing issues. Even after you put your product on the market. So the certification process today for AI algorithms in healthcare is a little bit like this. So you collect data, you train, you do a big expensive clinical trial, $1 million, $2 million, $10 million. At a certain moment in time, you get your regulatory approval, you deploy. And today, if you want to change your algorithm, you can start all over again. Now, regulators are working on iterative ways of working, where it's a more kind of iterative process, but this is still work in progress and still being defined. So that's a challenge as well, both from an investment point of view and from a practical point of view, because once you're in the market, you have access to a lot more data, but it's difficult to update your algorithm at this moment in time. So I really focus now a lot on challenges, but I don't want to make it sound too negative, because in fact there is a lot of opportunity of using AI in healthcare, and I also want to make sure that is heard properly. Just to give you one example here, what I really encourage everybody to do is, if you want to deploy an AI algorithm in healthcare and also in other industries, it's really good to think about how can it be much more than a mere replacement of a manual task. So if you only intend to replace a manual task by an AI algorithm, it's likely that it will not be adopted. Already for emotional, psychological reasons, because nobody wants to be replaced by an algorithm, but also because the added value of doing that in many cases is really, really limited. So the challenge and the opportunity at the same time is really thinking about, what can I do to change the paradigm, to change the way of working? For example, in the case of skin cancer, you could change the patient pathway. Today, patients typically go to a GP, but the GP refers them to the dermatologist. Patient has to wait months and months before you can get access to a dermatologist. If you have an AI algorithm, then it opens the potential to have a kind of priority route to a dermatologist. A GP could, for example, use a kind of risk scoring tool and then decide, based on that risk value that comes out, do I need to urgently refer, in which case the dermatologist can take that patient in between, or is it okay to wait for a little bit longer? But even further, screening and prevention. You could deploy AI algorithms in a screening context or a prevention context. Dermatology enabled by AI, second opinions by AI algorithms. So a dermatologist still makes diagnosis, but in parallel, an AI algorithm also reads it. By the way, this is something that in the UK is being done for breast cancer screening today already, for mammography. Improving treatments, trend analysis, and so on. So a lot of opportunities to really be much more than replacement of a manual task, and also increasing a lot of value there. But this is only possible if you think about it from the very beginning. So that's also a message I want to send. Think about early on, how can I really disrupt the space? And that will also put requirements on your other technical developments. Just one example of things that we are currently doing. This is in final clinical trial stage. Risk scoring for dermatology. So the concept is simple. You have a device, you can put it on the skin of the patient, you take an image, and then the AI algorithm will calculate a risk score, and that can be used by a dermatologist or in the future a GP to better take a decision on the patient. And maybe, you never know, in a few years, even to do autonomous second reads, but we're not there yet to support that. So taking a step back, drivers for broad adoption of AI in healthcare. What are they, in my opinion? Well, the first one I told you already, go beyond mere automation of human tasks. The second one is also a very crucial one. We need to go beyond scattered niche applications. If you look to the AI field in healthcare today, you have a few hundred AI solutions that are on the market, but they are all separated, they are all scattered. So in other words, if a hospital wants to invest in AI, they cannot just buy one system, they need to independently negotiate with 1, 2, 3, 5, 10, 20 different companies, different systems that all have their own UI, their own look and feel. This is just not working. So we need to go to an integrated solution where we can actually make use of AI in a standard way, where everything is brought together and it looks like one and the same way of working, one and the same interface. And also it needs to come out of a niche. So it needs to find applications where there is sufficient volume. Today, often AI algorithms are used only for the very complex cases, but these are things that happen like a few times per month. AI will really take off when we can go to volume applications. So how can that become possible? When you standardize interfaces, when you can integrate with electronic medical records, with other data sources, such that you go away from standalone applications, but you can build something that is really tapping into the existing ecosystem, the existing databases. Business, money is also very important. It needs to have a true attractive use case and a return of investment. If that's not there, then it will remain sporadic use and it will not be used in volume. And finding those use cases takes time. It often starts with a few innovators, a few pilot sites that use a system for a year, share their learnings, quantify return on investment, and then it picks off. Last one, we also really need a stable, flexible regulatory framework. The way it's working today is not future-proof. You cannot expect that a company invests a few $1 million to get an AI algorithm in the market, and then needs to start all over if they want to update the algorithm based on new data. And the regulators also understand that, and they're working really hard to come with proposals, with new frameworks to make iterative certifications possible, but this is still work in progress. So that will be crucial also towards the future. So in what stage is AI really in healthcare? Well, I'll give you my own opinion. So this is a typical Gartner adoption cycle that you see here. I would say 2019, 2020, we were really at the peak of the hype. So if you went to congresses on AI in healthcare, 1920, then it would be all over the Congress, AI, everybody would say, this will be used very broadly in 1 year. It will completely change the industry. So everybody was extremely enthusiastic and bullish about AI. In 2020, second half, 2021, we really dropped here to the bottom, and we went to the true of disillusionment. So I think we're now here. So we've seen the challenges in the past year. People started using AI in healthcare. We saw the challenges, the data integration, the scattered aspect of the different niches and apps and so on. And now we're slowly getting out. So the positive good news is that I believe that we are here now. So we're at the beginning of the slope of enlightenment. I truly believe that in the next few years, next 3, 4, 5 years, we will gradually, but for sure, see increased adoption of AI in healthcare applications. So it's really, really interesting times. Checking time here, perfect, almost half an hour. So to conclude, an AI algorithm can really be so much more than the mere replacement of a human task. You really need to understand the clinical workflow and from the beginning on have a clear vision and involve all the stakeholders. Often it's a combination of technological business payer models to really drive adoption. And ending with a positive note, I think it will happen now in the next 3, 4 years. We've went through the delusionment, and now we're ready to really see adoption coming. So really looking forward to the future. I think that was my last slide. Yes, thank you very much for sticking with me in this short 13 minutes. And I would like to open up the floor for questions. Thank you.